Problem number 4. On a copy of the exam that I printed out, there was a negative sign which didn't appear on my copy. I'll have to check and put that back in, but the problem should read 50, open parentheses, 1 minus e to the negative 0.3 t. If t is 0, then this entire exponent is 0, so this term would be 1. 1 minus 1 is 0. 50 times 0 is 0. So we're starting here at the origin. I'm only interested in graphing it for values of t that are positive. This is a problem that we've run into in WebAssign. It was used for a mixture problem. It's also used for terminal velocity for a skydiver. Now, as t increases, as t gets to be larger and larger in magnitude, this number, e to the minus 0.3t, is going to get smaller and smaller, getting very close to 0. So the inside is going to be heading towards 1, and in the long run, as t goes to infinity, y should be heading to 50. So I'm going to draw a horizontal line. I will label it y equals 50. I expect to rise and then flatten to this line. A variant of this that we ran into with population was the logistic curve. You should also be prepared to answer a question like that on the test. When it comes to graphing logarithms, unlike exponentials, I start on the inside. I ask myself, when will the inside be equal to 0? If the inside is 0, I'll have a vertical asymptote. Now that occurs when x is 1. So I draw my dashed line. I label it x equals 1. Next, I'm always interested in when the inside is equal to 1, because regardless of the base, the log of 1 is always 0. In this case, the inside is 1 when x is 0. If x is 0, I've got the log of 1, 0, negative 0, still 0. So this goes through the origin. It's a logarithm graph, so the only remaining question is whether it rises from negative infinity and then makes a turn and heads this way, or if it's coming from positive infinity, makes the turn and heads that way. Perhaps the simplest thing to do is figure out a value of logarithm that you do know. It's just log, the common log, so that's log base 10. The inside would be 10 when x was a negative 9. That would be out here somewhere. If x is negative 9, then I've got the log of 10, which is 1, and y would be a negative 1. So I'd go through a point way over here. So that tells me that the variation is that it comes from positive infinity. Log 10 makes a fairly sharp turn and heads out like so.